The stars awaken a certain reverence because, though always present, they are inaccessible. Ralph Waldo Emerson wrote these words nearly 200 years ago, and while much of his sentiment remains true today, distant stars and the planets they harbor are more accessible now than they have ever been. Just 30 years ago, we had not discovered a single planet beyond our own solar system, known as an exoplanet. Today, we know of more than 5,000, and we use these discoveries to study how planets form. I'm currently doing precisely that by searching for systems of exoplanets that resemble our own solar system. My work will uncover the relationship between Earth and its neighboring planets, a major step toward understanding the origins of habitable worlds. For over 3 years, NASA's Kepler Space Telescope continuously observed more than 150,000 stars, searching for brief dips in the star's brightness caused by a planet passing in front. Data from Kepler taught us that small planets close in to their host star are extremely common. On average, there is one such planet orbiting every sun-like star in the Milky Way galaxy. Another population that has come into focus is the distant giants. These planets are like Jupiter, large, gaseous, and far away from their host star. So close-in small planets are quite common, while distant giants are somewhat rare. Unfortunately, our discoveries of these two planet types come from almost completely separate stellar populations, so we don't understand how they affect each other's formation in the same system. For example, the planets in our own solar system are divided into two distinct subgroups. The presence of the inner rocky planets, Mercury, Venus, Earth, and Mars, and the outer giants, Jupiter and Saturn, could be evidence that these two planet types help each other form. But does this pattern exist in other systems? I'm currently leading a survey to answer this question by searching for distant giant planets in systems where an inner small planet is already known to exist. I've discovered 10 new giant planets already, and at the end of my survey, I will calculate the fraction of close-in small planets that are accompanied by a distant giant neighbor. This is an exciting result. With it, I can determine the conditions under which Earth-like planets form, bringing us closer to understanding our own solar system and the potential for life beyond it. Thank you.